Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss 3 multiple choice questions with only one correct option in projectile motion. The questions are as follows. Question 1. Two tall buildings are 40 meters apart. With what velocity should a ball be projected horizontally from a window 145 meters above the ground in one building so that it will enter a window 22.5 meters above the ground in the second building? Take acceleration due to gravity is equal to 9.8 meters per second square. The options are 4 meters per second, 6 meters per second, 8 meters per second, and 12 meters per second. Question 2. A particle is moving in a plane whose velocity is given by v is equal to v0 into I cap plus a omega cos omega t into j cap. If the particle is at the origin at time t is equal to 0, then the equation of trajectory of the particle is. The options are y is equal to a sin omega x by v0, y is equal to a cos omega x by v0, y is equal to a sin v0 by omega x, and y is equal to a cos v0 by omega x. Question 3. A body is projected from the ground with speed u, making angle theta with horizontal. Its horizontal range is 60 meters and time of flight is 3 seconds. Then the value of u is. Take acceleration due to gravity is equal to 10 meters per second square. The options are 20 meters per second, 25 meters per second, 30 meters per second, and 40 meters per second. First, let us solve the problem in question 1. The situation is shown in the figure. The ball is projected horizontally from window A, which is at height h1 is equal to 145 meters above ground level. The ball finally enters window B, which is at height h2 is equal to 22.5 meters above the ground. We will consider the motion of the ball from A to B, which follows a parabolic path as shown in the figure. Now, vertically downward distance covered by the ball is y is equal to h1 minus h2, which is equal to 122.5 meters. And the horizontal distance covered is x is equal to 40 meters. Acceleration due to gravity is acting in the vertically downward direction, hence the horizontal motion of the ball is uniform. Let the velocity of projection is equal to v in the horizontal direction. We are required to find the value of v. Therefore, the equation of uniform motion in the horizontal direction is x is equal to vx into t, and the equation of non-uniform motion in the downward direction is y is equal to uy into t plus half at square. Now, initial velocity in the downward direction is 0, therefore uy is equal to 0, which gives y is equal to half at square. Now, y is equal to minus 122.5 meters, a is equal to minus 9.8 meters per second square. Putting these values in equation 2, we get minus 122.5 is equal to minus half into 9.8 into t square. On simplification, this gives t is equal to 5 seconds. Putting this value in equation 1, we get v is equal to x by t, which is equal to 8 meters per second. Therefore, the correct option is C, which is the answer to question 1. Now, let us solve the problem in question 2. It is about a particle moving in the xy plane. Its velocity is given by v is equal to v0 into I cap plus a omega cos omega t into j cap. It is given that the particle is at the origin at time t is equal to 0. Therefore, when t is equal to 0, we have x is equal to 0 and y is equal to 0. If Vx and Vy be the x and y components of its velocity, then we have v is equal to Vx into I cap plus Vy into j cap. Comparing equations 1 and 2, we get Vx is equal to V0 and Vy is equal to a omega cos omega t. Now, Vx is equal to dx by dt and Vy is equal to dy by dt. Therefore, we write dx by dt is equal to V0 or dx is equal to V0 into dt. Integrating, we get integral dx is equal to integral V0 into dt. This implies x is equal to V0 into t plus c, where c is the constant of integration. Now, applying boundary condition x is equal to 0 when t is equal to 0, we get c is equal to 0. Therefore, we have x is equal to V0 into t. Similarly, dy by dt is equal to a omega cos omega t or dy is equal to a omega cos omega t into dt. Integrating, we get integral dy is equal to integral a omega cos omega t into dt. This implies y is equal to a omega into sin omega t divided by omega plus c dash, which is equal to a sin omega t plus c dash, where c dash is the constant of this integration. Now, applying boundary condition y is equal to 0 when t is equal to 0, we get c dash is equal to 0. Therefore, we have y is equal to a sin omega t. Now, equation 3 implies t is equal to x by v0. Putting this value in equation 4, we get y is equal to a sin omega x by v0. Therefore, the correct option is A, which is the answer to question 2. Finally, we will solve the problem in question 3. It is about a particle projected with initial velocity u, making angle theta with horizontal. Now, horizontal range of a projectile is given by r is equal to u square sine 2 theta divided by g, which is equal to 2u square sine theta into cos theta divided by g, and its time of flight is given by t is equal to 2u sine theta divided by g. It is given that r is equal to 60 meters, t is equal to 3 seconds, and g is equal to 10 meters per second square. Therefore, equation 2 gives 3 is equal to 2u sine theta divided by 10, which implies u sine theta is equal to 15 meters per second. Now, dividing equation 1 by equation 2, we get u cos theta is equal to r by t, which is equal to 20 meters per second. Now, squaring and adding equations 3 and 4, we get u square sine square theta plus u square cos square theta is equal to 15 square plus 20 square, or u square is equal to 625, which implies u is equal to 25 meters per second. Therefore, the correct option is B, which is the answer to question 3. This completes the answer to the questions.